Welcome to
Nay.
Do it.
Channel Everyone. Okay, deep breath. Hi everyone, welcome back. I am Isabel and today, wow, I have to say I am a little bit nervous and also very excited. We are talking about something called PRCO, Perception Reasoning Coevolution, and to help us understand this, I have two amazing guests. First, JJ, the master of making the complex sound simple.
Hello, Isabel. Thank you for having me. It's a pleasure to be here and no need to be nervous. We will climb this ladder together, step by step.
See, I told you, a calming presence, and our other guest is Xiong, who always asks the questions that make me go, oh, I hadn't thought of that.
Hello, happy to be here, and yes, I have some questions already.
Perfect, so, JJ, let's start at the very bottom of the ladder. For people like me, what is the basic problem PRCO is trying to solve? Why is it hard for these big AI models to answer questions about images?
A great starting point. Think of it like a detective team solving a case from a security camera photo. One detective, the observer, looks at the photo and writes down the evidence. The person is wearing a red hat. The other detective, the solver, reads that note and gives the final answer. That is suspect number 5.
Okay, I'm with you. Two detectives, one sees, one solves.
Exactly. Now, the old way to train this team was, you only check if the final answer is right. Yes, it was suspect number 5. Good job, team. But you don't know who did well. Did the observer write red hat correctly, or did the solver just guess? The reward is shared, so credit is blurred. The solver might get better at guessing, but the observer might not get better at seeing.
And this is a critical flaw, because if the observer extracts wrong evidence from the image, the foundation is rotten. The solver's reasoning, no matter how clever, is built on sand, garbage in, garbage out. This is a major bottleneck for reliable real-world systems.
Aha, so PRCO is like giving each detective their own performance review, their own specific reward.
Precisely. PRCO keeps it as one flexible model, one brain that can play both roles, but it uses two different reward signals. The solver role gets the classic reward, based on the final answer being correct, but the observer role gets a new kind of reward, a utility reward. It asks, how useful was my evidence caption for my partner, the solver? If the solver used the caption and succeeded, the observer gets a positive reward. They are now co-evolving, helping each other get better.
The cooperative aspect is key. It's not a zero-sum game. The observer isn't just trying to describe the image perfectly in a vacuum. It's learning to describe it in a way that is most useful for the specific question. That is a much smarter, more efficient form of perception.
That is actually beautiful. They're learning to work as a team. So, what happened when they tested this? Did the team get better?
The results were very consistent across 8 different challenging benchmarks, testing science questions, complex reasoning. The models trained with PRCO showed significant gains, an average improvement of over 7 accuracy points compared to the base model, and it outperformed other advanced training methods.
The data shows the observer's perception quality improved measurably. It wasn't just the solver's reasoning getting sharper, the evidence itself became more reliable. This directly addresses the bottleneck, but I have to push on the how. How is this utility reward for the observer actually calculated? That seems like a tricky thing to define without introducing new problems.
A fair question. The technical method involves something called a value function. It estimates the solver's probability of success given the observer's caption. So the observer is rewarded for generating captions that maximize the solver's expected chance of being correct. It's a proxy for usefulness, learned directly from the interaction.
So the observer is basically learning. What does my partner need to see to solve this case? I love that. It's like they're developing a shared language. This feels like a step towards more holistic understanding, not just separate parts bolted together.
Yes, the coevolution in the name is well chosen. It suggests a more integrated intelligence. However, we must be cautious. This is still a narrow form of cooperation within a single model's objectives. The real test is in messy open-world scenarios where the question isn't always clear. the social and ethical implications of training systems to optimize for internal utility, rather than human meaningful correctness, need careful thought.
That's an essential point. Thank you, Jiyoung, always bringing us back to the bigger picture. JJ, final thought from you. Where does this lead?
I see it as an important architectural insight. For building robust, trustworthy multimodal systems, we cannot treat perception and reasoning as separate problems. They must be trained in concert. PRCO offers an elegant pathway for that. It's a step toward models that don't just see, but see with purpose, and reason with grounded evidence.
See with purpose, I like that. Okay. My brain is full in the best way. Thank you so much, JJ and Jiyoung, for climbing this ladder with me today. This was fascinating.
Thank you, Isabel. It was a pleasure.
Thank you.
And thank you all for watching. We'll see you next time.